OAuth 2 with password and hashing, bearer with JWT tokens. Now that we have all the security flow, let's make the application actually secure, using JWT tokens and secure password hashing. This code is something you can actually use in your application, save the password hashes in your database, etc. We are going to start from where we left in the previous chapter and increment it. About JWT, JWT means JSON Web Tokens. It's a standard to codify a JSON object in a long, dense string without spaces. It looks like this. It is not encrypted, so anyone could recover the information from the contents. But it's signed. So, when you receive a token that you emitted, you can verify that you actually emitted it. That way, you can create a token with an expiration of, let's say, 1 week. And then when the user comes back the next day with the token, you know that user is still logged into your system. After a week, the token will be expired and the user will not be authorized and will have to sign in again to get a new token. And if the user or a third party tried to modify the token to change the expiration, you would be able to discover it because the signatures would not match. If you want to play with JWT tokens and see how they work, check https JWT.io. Install PyJWT. We need to install PyJWT to generate and verify the JWT tokens in Python. Make sure you create a virtual environment internal link target equals blank, activate it, and then install Pidgeot. Info if you're planning to use digital signature algorithms like RSA or ECDSA, you should install the cryptography library dependency Pidgeot Crypto. You can read more about it in the PyJWT installation docs. Password hashing. Hashing means converting some content, a password in this case, into a sequence of bytes, just a string that looks like gibberish. Whenever you pass exactly the same content, exactly the same password, you get exactly the same gibberish. But you cannot convert from the gibberish back to the password. Why use password hashing if your database is stolen? The thief won't have your users' plaintext passwords, only the hashes. So, the thief won't be able to try to use that password in another system, as many users use the same password everywhere. This would be dangerous. Install passlib. Passlib is a great Python package to handle password hashes. It supports many secure hashing algorithms and utilities to work with them. The recommended algorithm is bcrypt. Make sure you create a virtual environment internal link target equals blank, activate it, and then install passlib with bcrypt. Tip with passlib, you could even configure it to be able to read passwords created by Django, a Flask security plugin, or many others. So, you would be able to, for example, share the same data from a Django application in a database with a fastAPI application, or gradually migrate a Django application using the same database. And your users would be able to log in from your Django app or from your fastAPI app at the same time. Hash and verify. The passwords import the tools we need from passlib. Create a passlib context. This is what will be used to hash and verify passwords. Tip: the passlib context also has functionality to use different hashing algorithms, including deprecated old ones only to allow verifying them, etc. For example, you could use it to read and verify passwords generated by another system like Django, but hash any new passwords with a different algorithm like bcrypt, and be compatible with all of them at the same time. Create a utility function to hash a password coming from the user, and another utility to verify if a received password matches the hash stored, and another one to authenticate and return a user. Note if you check the new fake database FACusersDB, you will see how the hashed password looks like now. 2B $12 Ix ZAWYVK 1 FSBW 1 ZFBX3 OZ pod WXN 96P36 W code G6 LRUG 3 VJ PGGA 31 LW. Handle JWT tokens. Import the modules installed. Create a random secret key that will be used to sign the JWT tokens. To generate a secure random secret key, use the command, and copy the output to the variable secretkey. Don't use the one in the example. Create a variable algorithm with the algorithm used to sign the JWT token and set it to HS256. Create a variable for the expiration of the token. Define a pydantic model that will be used in the token endpoint for the response. Create a utility function to generate a new access token. Update the dependencies update getGuarantor to receive the same token as before, but this time using JWT tokens. Decode the received token, verify it, and return the current user. If the token is invalid, return an HTTP error right away. Update the token path operation, create a time delta with the expiration time of the token. Create a real JWT access token and return it. Technical details about the JWT subject. The JWT specification says that there's a key sub with the subject of the token. It's optional to use it, but that's where you would put the user's identification, so we are using it here. JWT might be used for other things apart from identifying a user and allowing them to perform operations directly on your API. For example, you could identify a car or a blog post. Then you could add permissions about that entity, like drive for the car or edit for the blog. And then you could give that JWT token to a user or bot, and they could use it to perform those actions, drive the car, or edit the blog post without even needing to have an account, just with the JWT token your API generated for that. Using these ideas, JWT can be used for way more sophisticated scenarios. In those cases, several of those entities could have the same ID. Let's say foo a user foo, a car foo, and a blog post foo. So to avoid ID collisions, when creating the JWT token for the user, you could prefix the value of the subkey, e.g. with username. So in this example, the value of sub could have been username, John Doe. The important thing to keep in mind is that the subkey should have a unique identifier across the entire application, and it should be a string. Check it run the server and go to the docs. HTTP 127.0.0.1.8000 docs. You'll see the user interface like, authorize the application the same way as before. Using the credentials, username, John Doe password. Secret check, notice that nowhere in the code is the plaintext password secret, we only have the hashed version. Call the endpoint. Users me, you will get the response as. If you open the developer tools, you could see how the data sent only includes the token. The password is only sent in the first request to authenticate the user and get Get that access token, but not afterwards. Notice the header authorization, with a value that starts with bearer. Advanced usage with scopes OAuth2 has the notion of scopes. You can use them to add a specific set of permissions to a JWT token. Then you can give this token to a user directly or a third party to interact with your API with a set of restrictions. You can learn how to use them and how they are integrated into fastAPI later in the Advanced User Guide. Recap with what you have seen up to now. You can set up a secure fastAPI application using standards like OAuth2 and JWT. In almost any framework, handling the security becomes a rather complex subject quite quickly. Many packages that simplify it a lot have to make many compromises with the data model, database, and available features. And some of these packages that simplify things too much actually have security flaws underneath. fastAPI doesn't make any compromise with any database, data model, or tool. It gives you all the flexibility to choose the ones that fit your project the best. And you can use directly many well-maintained and widely used packages like passlib and pyjwt, because fastAPI doesn't require any complex mechanisms to integrate external packages. But it provides you the tools to simplify the process as much as possible without compromising flexibility, robustness, or security. And you can use and implement secure, standard protocols, like OAuth2 in a relatively simple way. You can learn more in the Advanced User Guide about how to use OAuth2 scopes for a more fine-grained permission system following these same standards. OAuth2 with scopes is the mechanism used by many big authentication providers like Facebook, Google, GitHub, Microsoft, Twitter, etc. to authorize third-party applications to interact with their APIs on behalf of their users. Middleware. You can add middleware to fastAPI applications. A middleware is a function that works with every request before it is processed by any specific path operation, and also with every response before returning it. It takes each request that comes to your application. It can then do something to that request or run any needed code. Then it passes the request to be processed by the rest of the application by some path operation. It then takes the response generated by the application by some path operation. It can do something to that response or run any middleware. You can add middleware to fastAPI applications. A middleware is a function that works with every request before it is processed by any specific path operation, and also with every response before returning it. It takes each request that comes to your application. It can then do something to that request or run any needed code. Then it passes the request to be processed by the rest of the application by some path operation. It then takes the response generated by the application by some path operation. It can do something to that response or run any needed code. Then it returns the response. Note technical details: if you have dependencies with yield, the exit code will run after the middleware. If there were any background tasks covered in the background tasks internal link target equals blank section, you will see it later. They will run after all the middleware. Create a middleware. To create a middleware, you use the decorator at app middleware HTTP on top of a function. The middleware function receives the request, a function call next that will receive the request as a parameter. This function will pass the request to the corresponding path operation. Then it returns the response generated by the corresponding path operation. You can then further modify the response before returning it. Tip: keep in mind that custom proprietary headers can be added using the X prefix. But if you have custom headers that you want a client in a browser to be able to see, you need to add them to your CORS configurations. CORS cross-origin resource sharing internal link target equals blank using the parameter expose headers documented in Starlet's CORS docs. Note technical details you could also use from Starlet. Requests import request. fastAPI provides it as a convenience for you, the developer, but it comes directly from Starlet. Before and after the response, you can add code to be run with the request before any path operation receives it, and also after the response is generated before returning it. For example, you could add a custom header xProcess time containing the time in seconds that it took to process the request and generate a response. Tip: here we use time perf counter instead of time because it can be more precise for these use cases. Nerd face multiple middleware execution order when you add multiple middlewares using either at app middleware decorator or app add middleware method. Each new middleware wraps the application, forming a stack. The last middleware added is the outermost, and the first is the innermost. On the request path, the outermost middleware runs first. On the response path, it runs last. For example, this results in the following execution order: request, middleware B right arrow middleware A right arrow root response. Root middleware A right arrow middleware B. This stacking behavior ensures that middlewares are executed in a predictable and controllable order. Other middlewares: you can later read more about other middlewares in the Advanced User Guide. Advanced Middleware Internal Link Target equals blank. You will read about how to handle CORS with a middleware in the next section. CORS cross-origin resource sharing. CORS, or cross-origin resource sharing, refers to the situations when a front-end running in a browser has JavaScript code that communicates with a backend, and the backend is in a different origin than the front-end. Origin and origin is the combination of protocol HTTP, HTTPS, domain MyApp, COM, localhost, Tiangelo, COM, and port 80, 443, 8080. So all these are different origins. HTTP, localhost HTTPS, localhost HTTP, localhost 8080. Even if they are all in localhost, they use different protocols or ports, so they are different origins. Step so, let's say you have a front end running in your browser at HTTP. Localhost 8080, and its JavaScript is trying to communicate with a backend running at HTTP. Localhost, because we don't specify a port, the browser will assume the default port 80. Then, the browser will send an HTTP options request to the 80 backend, and if the backend sends the appropriate headers authorizing the communication from this different origin HTTP. Localhost 8080, then, the 8080 browser will let the JavaScript in the front end send its request to the 80 backend. To achieve this, the 80 backend must have a list of allowed origins. In this case, the list would have to include HTTP, localhost 8080 for the 8080 frontend to work correctly. Wildcards, it's also possible to declare the list as a wildcard to say that all are allowed. But that will only allow certain types of communication, excluding everything that involves credentials, cookies, authorization headers like those used with bearer tokens, etc. So, for everything to work correctly, it's better to specify explicitly the allowed origins. Use CORS middleware. You can configure it in your fastAPI application using the CORS middleware. Import CORS middleware. Create a list of allowed origins as strings. Add it as a middleware to your fastAPI application. You can also specify whether your backend allows credentials, authorization headers, cookies, etc. specific HTTP methods, POST, PUT, or all of them with the wildcard. Specific HTTP headers or all of them with the wildcard. The default parameters used by the CORS middleware implementation are restrictive by default, so you'll need to explicitly enable particular origins, methods, or headers in order for browsers to be permitted to use them in a cross-domain context. The following arguments are supported: allow origins, a list of origins that should be permitted to make cross-origin requests, e.g. HTTPS, example.org, HTTPS, www.example.org. You can use to allow any origin, allow origin regex, a regex string to match against origins that should be permitted to make cross-origin requests, e.g. HTTPS, example.org, allow methods, a list of HTTP methods that should be allowed for cross-origin requests, defaults to get. You can use to allow all standard methods, allow headers, a list of HTTP request headers that should be supported for cross-origin requests, defaults to. You can use to allow all headers. The accept language, and content type headers are always allowed for simple CORS requests. Allow credentials, indicate that cookies should be supported for cross-origin requests, defaults to false. None of allow origins, allow methods, and allow headers can be set to if allow credentials is set to true. All of them must be explicitly specified. Expose headers, indicate any response headers that should be made accessible to the browser, defaults to. Maxage sets a maximum time in seconds for browsers to cache CORS responses, defaults to 600. The middleware responds to two particular types of HTTP request. CORS preflight requests. These are any options request with origin and access control request method headers. In this case, the middleware will intercept the incoming request and respond with appropriate CORS headers, and either a 200 or 400 response for informational purposes. Simple requests, any request with an origin header. In this case, the middleware will pass the request through as normal, but will include appropriate CORS headers on the response. More info about CORS, check the Mozilla CORS documentation. Note technical details you could also use from Starlet. Middleware, CORS, import CORS middleware. fastAPI provides several middlewares in fastAPI, middleware just as a convenience for you, the developer. But most of the available middlewares come directly from Starlet. SQL relational databases, fastAPI doesn't require you to use a SQL relational database, but you can use any database that you want. Here we'll see an example using SQL Model. SQL Model is built on top of SQL Alchemy and Pydantic. It was made by the same author of fastAPI to be the perfect match for fastAPI applications that need to use SQL databases. Tip: you could use any other SQL or NoSQL database library you want, in some cases called ORMs. fastAPI doesn't force you to use anything. Smiling face with sunglasses as SQL Model is based on SQL Alchemy. You can easily use any database supported by SQL Alchemy, which makes them also supported by SQL Model, like PostgreSQL, MySQL SQ, Lite, Oracle, Microsoft SQL Server, etc. In this example, we'll use SQLite because it uses a single file and Python has integrated support. So, you can copy this example and run it as is. Later, for your production application, you might want to use a database server like PostgreSQL. Tip: there is an official project generator with fastAPI and PostgreSQL, including a front end and more tools. https GitHub.com fastAPI full stack fastAPI template. This is a very simple and short tutorial. If you want to learn about databases in general, about SQL, or more advanced features, go to the SQL Model docs. Install SQL Model first. Make sure you create your virtual environment. Internal link target equals blank. Activate it, and then install SQL Model. Create the app with a single model. We'll create the simplest first version of the app with a single SQL model first. Later, we'll improve it, increasing security and versatility with multiple models below. Nerdface: create models, import SQL model, and create a database model. The hero class is very similar to a Pydantic model. In fact, underneath, it actually is a Pydantic model. There are a few differences. Table equals true tells SQL model that this is a table model. It should represent a table in the SQL database. It's not just a data model, as would be any other regular Pydantic class. Field primary key equals true tells SQL model that the id is the primary key in the SQL database. You can learn more about SQL primary keys in the SQL Model docs. By having the type as int none, SQL Model will know that this column should be an integer in the SQL database, and that it should be nullable. Field index equals true tells SQL Model that it should create a SQL index for this column that would allow faster lookups in the database when reading data filtered by this column. SQL Model will know that something declared as str will be a SQL column of type text or varchar, depending on the database. Create an engine. A SQL Model engine, underneath it's actually a SQL Alchemy engine, is what holds the connections to the database. You would have one single engine object for all your code to connect to the same database. Using checksumMethod equals false allows fastAPI to use the same SQLite database in different threads. This is necessary as one single request could use more than one thread, for example, in dependencies. Don't worry, with the way the code is structured, we'll make sure we use a single SQL model session per request later. This is actually what the checksumMethod is trying to achieve. Create the tables. We then add a function that uses SQL model metadata. Create a engine to create the tables for all the table models. Create a session dependency. A session is what stores the objects in memory and keeps track of any changes needed in the data. Then it uses the engine to communicate with the database. We will create a fastAPI dependency with yield that will provide a new session for each request. This is what ensures that we use a single session per request. Nerdface, then we create an annotated dependency session dep to simplify the rest of the code that will use this dependency. Create database tables on startup. We will create the database tables when the application starts. Here we create the tables on an application startup event. For production, you would probably use a migration script that runs before you start your app. Nerdface tip SQL model will have migration utilities wrapping Alembic, but for now, you can use Alembic directly. Create a hero because each SQL model is also a Pydantic model. You can use it in the same type annotations that you could use Pydantic models. For example, if you declare a parameter of type hero, it will be read from the JSON body. The same way, you can declare it as the function's return type, and then the shape of the data will show up in the automatic API docs UI. Here we use the session.dep dependency a session to add the new hero to the session instance, commit the changes to the database, refresh the data in the hero, and then return it. Read heroes, we can read heroes from the database using a select. We can include a limit and offset to paginate the results. Read one hero, we can read a single hero. Delete a hero, we can also delete a hero. Run the app, you can run the app. Then go to the Docs UI. You will see that fastAPI is using these models to document the API, and it will use them to serialize and validate the data too. Update the app with multiple models. Now let's refactor this app a bit to increase security and versatility. If you check the previous app, in the UI you can see that, up to now, it lets the client decide the id of the hero to create. Face screaming in fear, we shouldn't let that happen. They could overwrite an id we already have assigned in the DB. Deciding the id should be done by the backend or the database, not by the client. Additionally, we create a secret name for the hero, but so far, we are returning it everywhere. That's not very secret. Grinning face with sweat will fix these things by adding a few extra models. Here's where SQL model will shine. Sparkles create multiple models in SQL model. Any model class that has table equals true is a table model. And any model class that doesn't have table equals true is a data model. These ones are actually just pedantic models with a couple of small extra features. Nerd face with SQL model, we can use inheritance to avoid duplicating all the fields in all the cases. Hero base, the base class, let's start with a hero base model that has all the fields that are shared by all the models. Name age hero, the table model, then let's create hero, the actual table model, with the extra fields that are not always in the other models. Id secret name, because hero inherits from hero base, it also has the fields declared in hero base, so all the fields for hero are. Id name age secret name hero public, the public data model. Next, we create a hero public model. This is the one that will be returned to the clients of the API. It has the same fields as hero base, so it won't include secret name. Finally, the identity of our heroes is protected. It also redeclares int. By doing this, we are making a contract with the API clients so that they can always expect the id to be there, and to be an int, it will never be none. Tip: having the return model ensure that a value is always available, and always int not none is very useful for the API clients. They can write much simpler code having this certainty. Also, automatically generated clients will have simpler interfaces, so that the developers communicating with your API can have a much better time working with your API. All the fields in Hero Public are the same as in Hero Base, with id declared as int not none. Id name age hero create, the data model to create a hero. Now we create a hero create model. This is the one that will validate the data from the clients. It has the same fields as Hero Base, and it also has secret name. Now, when the clients create a new hero, they will send the secret name. It will be stored in the database, but those secret names won't be returned in the API to the clients. Tip: this is how you would handle passwords. Receive them, but don't return them in the API. You would also hash the values of the passwords before storing them, never store them in plain text. The fields of hero create are name age secret name hero update, the data model to update a hero. We didn't have a way to update a hero in the previous version of the app, but now with multiple models, we can do it. Party Popper, the hero update data model, is somewhat special. It has all the same fields that would be needed to create a new hero, but all the fields are optional. They all have a default value. This way, when you update a hero, you can send just the fields that you want to update. Because all the fields actually change, the type now includes none, and they now have a default value of none, we need to redeclare them. We don't really need to inherit from hero base because we are redeclaring all the fields. I'll leave it inheriting just for consistency, but this is not necessary. It's more a matter of personal taste. Person shrugging, the fields of hero update are name age secret name create with hero create and return a hero public. Now that we have multiple models, we can update the parts of the app that use them. We receive in the request a hero create data model, and from it, we create a hero table model. This new table model hero will have the fields sent by the client and will also have an id generated by the database. Then we return the same table model hero as is from the function. But as we declare the response model with the hero public data model, fastAPI will use hero public to validate and serialize the data. Tip now, we use response model equals hero public instead of the return type annotation. Hero public because the value that we are returning is actually not a hero public. If we had declared hero public, your editor and linter would complain rightfully so that you are returning a hero instead of a hero public. By declaring it in response model, we are telling fastAPI to do its thing, without interfering with the type annotations and the help from your editor and other tools. Read heroes with hero public, we can do the same as before to read heroes. Again, we use response model equals list hero public to ensure that the data is validated and serialized correctly. Read one hero with hero public, we can read a single hero. Update a hero with hero update, we can update a hero. For this, we use an HTTP patch operation. And in the code, we get a dict with all the data sent by the client, only the data sent by the client, excluding any values that would be there just for being the default values. To do it, we use exclusion set equals true. This is the main trick. Then we use HeroDB, SQL model update hero data to update the HeroDB with the data from hero data. Delete a hero again, deleting a hero stays pretty much the same. We won't satisfy the desire to refactor everything in this one. Grinning face with sweat, run the app again, you can run the app again. If you go to the Docs API UI, you will see that it is now updated, and it won't expect to receive the id from the client when creating a hero, etc. Recap, you can use SQL model to interact with a SQL database and simplify the code with data models and table models. You can learn a lot more at the SQL model docs. There's a longer mini tutorial on using SQL model with fastAPI. Rocket.
Rocket.
Kokoro TTS is an open source.
Second nature for you. You're going to be like, oh, well, I gotta. Okay, and I'm going to show you some features of this. We'll go to your chat GPT and just throw. And then, oh, God, I got rapids. I'm going to know it. So it says it's written in the International Phonetic Alphabet.
Bigger applications, multiple files if you're building an application or a web API, it's rarely the case that you can put everything in a single file. fastAPI provides a convenience tool to structure your application while keeping all the flexibility. Info, if you come from Flask, this would be the equivalent of Flask's blueprints. An example file structure, let's say you have a file structure like this. Tip, there are several in it, Pi files, one in each directory or subdirectory. This is what allows importing code from one file into another. For example, in app main, Pi you could have a line like, the app directory contains everything, and it has an empty file app in it. Pi, so it is a Python package, a collection of Python modules, app. It contains an app main, Pi file, as it is inside a Python package, a directory with a file in it. Pi, it is a module of that package, app main. There's also an app dependencies. Pi file, just like app main, Pi, it is a module, app dependencies. There's a subdirectory app routers with another file in it. Pi, so it's a Python subpackage, app routers. The file app routers items. Pi is inside a package, app routers, so it's a submodule, app.routers.items. The same with app routers users. Pi, it's another submodule, app.routers.users. There's also a subdirectory app internal with another file in it. Pi, so it's another Python subpackage, app internal. And the file app internal admin. Pi is another submodule, app.internal.admin. The same file structure with comments. API router, let's say the file dedicated to handling just users, is the submodule at app routers users. Pi. You want to have the path operations related to your users separated from the rest of the code to keep it organized. But it's still part of the same fastAPI application, Web API. It's part of the same Python package. You can create the path operations for that module using API router. Import API router, you import it and create an instance, the same way you would with the class fastAPI. Path operations with API router, and then you use it to declare your path operations. Use it the same way you would use the fastAPI class. You can think of API router as a mini fastAPI class. All the same options are supported. All the same parameters, responses, dependencies, tags, etc. Tip in this example, the variable is called router, but you can name it however you want. We are going to include this API router in the main fastAPI app, but first, let's check the dependencies and another API router. Dependencies, we see that we are going to need some dependencies used in several places of the application, so we put them in their own dependencies module app dependencies. Pi. We will now use a simple dependency to read a custom XToken header. Tab Python 3.9 plus tab Python 3.8 plus tab Python 3.8 plus non-annotated tip. Prefer to use the annotated version if possible. Tip, we are using an invented header to simplify this example. But in real cases, you will get better results using the integrated security utilities internal link target equals blank. Another module with API router, let's say you also have the endpoints dedicated to handling items from your application in the module at app routers items. Pi. You have path operations for items, item it. It's all the same structure as with app routers users. Pi. But we want to be smarter and simplify the code a bit. We know all the path operations in this module have the same path prefix, items, tags, just one tag, items, extra responses. Dependencies, they all need that XToken dependency we created. So, instead of adding all that to each path operation, we can add it to the API router. As the path of each path operation has to start with, like in, the prefix must not include a final. So, the prefix in this case is items. We can also add a list of tags and extra responses that will be applied to all the path operations included in this router. And we can add a list of dependencies that will be added to all the path operations in the router and will be executed solved for each request made to them. Tip, note that, much like dependencies in path operation decorators internal link target equals blank, no value will be passed to your path operation function. The end result is that the item paths are now items, itemid, as we intended. They will be marked with a list of tags that contain a single string, items. These tags are especially useful for the automatic interactive documentation systems using OpenAPI. All of them will include the predefined responses. All these path operations will have the list of dependencies evaluated executed before them. If you also declare dependencies in a specific path operation, they will be executed too. The router dependencies are executed first, then the dependencies in the decorator internal link target equals blank, and then the normal parameter dependencies. You can also add security dependencies with scopes internal link target equals blank. Tip, having dependencies in the API router can be used, for example, to require authentication for a whole group of path operations, even if the dependencies are not added individually to each one of them. Check the prefix, tags, responses, and dependencies parameters are, as in many other cases, just a feature from fastAPI to help you avoid code duplication. Import the dependencies. This code lives in the module app routers items, the file app routers items, Pi. And we need to get the dependency function from the module app dependencies, the file app dependencies, Pi. So we use a relative import with. For the dependencies, how relative imports work. Tip, if you know perfectly how imports work, continue to the next section below. A single dot, like in, would mean starting in the same package that this module, the file app routers items, Pi lives in the directory app routers. Find the module dependencies in imaginary file at app routers dependencies, Pi, and from it, import the function getTokenHeader. But that file doesn't exist. Our dependencies are in a file at app dependencies, Pi. Remember how our app file structure looks like. The two dots, like in, mean, starting in the same package that this module, the file app routers items, Pi lives in the directory app routers. Go to the parent package, the directory app, and in there, find the module dependencies, the file at app dependencies, Pi, and from it, import the function getTokenHeader. That works correctly. party popper the same way if we had used 3 dots. Like in, that would mean, starting in the same package that this module, the file app routers items, Pi lives in the directory app routers, go to the parent package, the directory app. Then go to the parent of that package, there's no parent package, app is the top level face screaming in fear. And in there, find the module dependencies, the file at app dependencies, Pi, and from it, import the function getOken header. That would refer to some package above app with its own file in it, Pi, etc. But we don't have that. So that would throw an error in our example. Police car light, but now you know how it works, so you can use relative imports in your own apps no matter how complex they are. Nerdface adds some custom tags, responses, and dependencies. We are not adding the prefix items nor the tags equals items to each path operation because we added them to the API router. But we can still add more tags that will be applied to a specific path operation, and also some extra responses specific to that path operation. Tip: this last path operation will have the combination of tags, items, custom, and it will also have both responses in the documentation, one for 404 and one for 403. The main fastAPI now, let's see the module at app main, Pi. Here's where you import and use the class fastAPI. This will be the main file in your application that ties everything together. And as most of your logic will now live in its own specific module, the main file will be quite simple. Import fastAPI, you import and create a fastAPI class as normally. And we can even declare global dependencies internal link target equals blank that will be combined with the dependencies for each API router. Import the API router, now we import the other submodules that have API routers. As the file's app routers users, Pi and app routers items. Pi are submodules that are part of the same Python package app. We can use a single dot to import them using relative imports. How the importing works: the section means starting in the same package that this module, the file app main, Pi lives in the directory app. Look for the subpackage routers, the directory at app routers, and from it, import the submodule items, the file at app routers items. Pi and users, the file at app routers users, Pi. The module items will have a variable router items router. This is the same one we created in the file app routers items, Pi. It's an API router object. And then we do the same for the module users. We could also import them like info. The first version is a relative import. The second version is an absolute import. To learn more about Python packages and modules, read the official Python documentation about modules. Avoid name collisions, we are importing the submodule items directly, instead of importing just its variable router. This is because we also have another variable named router in the submodule users. If we had imported one after the other, like, the router from users would overwrite the one from items, and we wouldn't be able to use them at the same time. So, to be able to use both of them in the same file, we import the submodules directly. Include the API routers for users and items now. Let's include the routers from the submodules users and items. Info users router contains the API router inside of the file app routers users, Pi. And items router contains the API router inside of the file app routers items, Pi. With app, include a router, we can add each API router to the main fastAPI application. It will include all the routes from that router as part of it. Note technical details, it will actually internally create a path operation for each path operation that was declared in the API router. So, behind the scenes, It will actually work as if everything was the same single app. Check you don't have to worry about performance when including routers. This will take microseconds and will only happen at startup, so it won't affect performance. High voltage include an API router with a custom prefix, tags, responses, and dependencies now. Let's imagine your organization gave you the app internal admin, PI file. It contains an API router with some admin path operations that your organization shares between several projects. For this example, it will be super simple. But let's say that because it is shared with other projects in the organization, we cannot modify it and add a prefix, dependencies, tags, etc. directly to the API router. But we still want to set a custom prefix when including the API router so that all its path operations start with admin. We want to secure it with the dependencies we already have for this project, and we want to include tags and responses. We can declare all that without having to modify the original API router by passing those parameters to app, include a router. That way, the original API router will stay unmodified, so we can still share that same app internal admin, PI file with other projects in the organization. The result is that in our app, each of the path operations from the admin module will have the prefix admin, the tag admin, the dependency getToken header, the response 418. Teacup without handle, but that will only affect that API router in our app, not in any other code that uses it. So, for example, other projects could use the same API router with a different authentication method. Include a path operation, we can also add path operations directly to the fastAPI app. Here we do it. Just to show that we can person shrugging, and it will work correctly, together with all the other path operations added with app, include a router. Info very technical details note, this is a very technical detail that you probably can just skip. The API routers are not mounted, they are not isolated from the rest of the application. This is because we want to include their path operations in the OpenAPI schema and the user interfaces. As we cannot just isolate them and mount them independently of the rest, the path operations are cloned, recreated, not included directly. Check the automatic API docs now, run your app, and open the docs at http 127.0.0.1.8000 docs. You will see the automatic API docs, including the paths from all the submodules, using the correct paths and prefixes and the correct tags. Include the same router multiple times with different prefix you can also use. Include a router multiple times with the same router using different prefixes. This could be useful, for example, to expose the same API under different prefixes, e.g. API v1 and API latest. This is an advanced usage that you might not really need, but it's there in case you do. Include an API router in another the same way you can include an API router in a fastAPI application. You can include an API router in another API router using. Make sure you do it before including router in the fastAPI app, so that the path operations from other router are also included. Background tasks, you can define background tasks to be run after returning a response. This is useful for operations that need to happen after a request, but that the client doesn't really have to be waiting for the operation to complete before receiving the response. This includes, for example, email notifications sent after performing an action. As connecting to an email server and sending an email tends to be slow, several seconds, you can return the response right away and send the email notification in the background. Processing data. For example, let's say you receive a file that must go through a slow process. You can return a response of accepted, HTTP 202, and background tasks, you can define background tasks to be run after returning a response. This is useful for operations that need to happen after a request, but that the client doesn't really have to be waiting for the operation to complete before receiving the response. This includes, for example, email notifications sent after performing an action. As connecting to an email server and sending an email tends to be slow, several seconds, you can return the response right away and send the email notification in the background. Processing data. For example, let's say you receive a file that must go through a slow process. You can return a response of accepted, HTTP 202, and process the file in the background. Using background tasks first, import background tasks, and define a parameter in your path operation function with a type declaration of background tasks. fastAPI will create the object of type background tasks for you and pass it as that parameter. Create a task function, create a function to be run as the background task. It is just a standard function that can receive parameters. It can be an async def or normal def function. fastAPI will know how to handle it correctly. In this case, the task function will write to a file simulating sending an email. And as the write operation doesn't use async and await, we define the function with normal def. Add the background task inside of your path operation function. Pass your task function to the background tasks object with the method addTask. addTask receives as arguments a task function to be run in the background write notification. Any sequence of arguments that should be passed to the task function in order email. Any keyword arguments that should be passed to the task function message equals some notification. Dependency injection using background tasks also works with the dependency injection system. You can declare a parameter of type background tasks at multiple levels. In a path operation function, in a dependency dependable, in a subdependency, etc. fastAPI knows what to do in each case and how to reuse the same object, so that all the background tasks are merged together and are run in the background afterwards. In this example, the messages will be written to the log txt file after the response is sent. If there was a query in the request, it will be written to the log in a background task. And then another background task generated at the path operation function will write a message using the email path parameter. Technical details, the class background tasks comes directly from Starlet, background. It is included directly into fastAPI so that you can import it from fastAPI and avoid accidentally importing the alternative background task without the S at the end from Starlet. Background. By only using background tasks and not background task, it's then possible to use it as a path operation function parameter and have fastAPI handle the rest for you, just like when using the request object directly. It's still possible to use background task alone in fastAPI, but you have to create the object in your code and return a Starlet response including it. You can see more details in Starlet's official docs for background tasks. Caveat: if you need to perform heavy background computation and you don't necessarily need it to be run by the same process. For example, you don't need to share memory, variables, etc. You might benefit from using other bigger tools like Celery. They tend to require more complex configurations, a message job queue manager, like RabbitMQ or Redis, but they allow you to run background tasks in multiple processes, and especially in multiple servers. But if you need to access variables and objects from the same fastAPI app, or you need to perform small background tasks like sending an email notification, you can simply just use background tasks. Recap import and use background tasks with parameters in path operation functions and dependencies to add background tasks.
Hello.
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 Hi, Chirag Patil.
Yes. Who is this?
Yeah, Mr. Chirag, Akhilesh this side. I'm calling you from study abroad.
What's up everyone, it's Brace from LangChain, and now I hit send, and it's rendering this nice UI for us to interact. Y is the sky, which is key. You can interact with it with this UI 4 and generating. And while this is running, we can open it up in my IDE site using just plain agent chat app. So I'm going to show you now how you can do this locally. We pulled in all the different code, deployed graph, not a local one. Weather, it's then going to call the get weather function with City of New York, and it's going to call the get weather function and get the actual weather. This is the tool result, this is the tool call, and we can see it summarizes that down here. So that is how you connect to a deployment URL, run it locally, use the npx create agent chat app command, use the